In this video, I'm going to derive the formula for the derivative of f inverse of x. Okay, now before we derive the formula, I want to try to explain the formula. Okay, what does this formula mean? And the formula is right up here in the upper left corner. So the left-hand side says the derivative of f inverse of x. Okay, the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. Okay, now be careful here. This does not say f prime times f inverse of x. It says f prime of f inverse of x. So what does the formula mean? Well, I've drawn a picture of a function f in red here, and notice this function is one-to-one. Its graph passes the horizontal line test. Any horizontal line you draw is only going to intersect the graph at most at one point. Okay, so since f is one-to-one, since its graph passes the horizontal line test, it will have an inverse function. And I've drawn the inverse function over here in blue. Okay, and notice that f inverse is just the reflection of the graph of f across the line y equals x. These graphs are reflections across this line. Now let's take a particular point on f, and let's suppose the coordinates here are 3, 7. Okay, now what does it mean to say that 3, 7 is on the graph of f? Well, it means that f of 3 is equal to 7. Okay, now if f of 3 is equal to 7, f inverse of 7 will equal 3. Okay, really just that's what f inverse means. If f of 3 is 7, f inverse of 7 will be 3. So the point 7, 3 is going to be on the graph of f inverse. Now where is that point? Well, 7, 3 is just the reflection of the point 3, 7 across that line y equals x. Okay, notice the x coordinate here is 7, x coordinate right here is 3. Okay, now what we're really interested in though is what is the slope of the tangent line at these 2 points. Okay, what's the slope of the tangent line? Okay, how are these slopes related to each other? Now notice they're not the same slope. Okay, this line certainly looks like it's steeper than this line. Okay, but what the formula is going to tell us, what this formula up here is going to tell us, is that the slope of these two lines are reciprocals of each other. Okay, if this line has slope 5, then this line would have slope 1/5. Okay, these slopes are reciprocals of each other. Now, why does that formula tell us that? Well, this formula has to be true for all values of x. So in particular, it has to be true for x equals 7. Okay, so let's just plug in 7 into this formula and see what we get. So what I would say is f inverse prime of 7 is equal to 1 over f prime of f inverse of 7. Okay, we just plugged in 7 for x in both of these spots. Now this is equal to 1 over f prime of what? Well, what is f inverse of 7? F inverse of 7 is 3. So this is just 1 over f prime of 3. Now what does this formula really tell us? It says that f inverse prime of 7. What does that mean? That means that the slope of f inverse, the slope of the graph of f inverse at 7, so that's really the slope of this line. Okay, this left-hand side is the slope of this line, is equal to 1 over f prime of 3. Okay, what's f prime of 3? That's the slope of this line. Okay, here's the graph of f. F prime of 3 would be the slope of the tangent line at 3. Okay, now be a little careful here. This does not say that f inverse prime of 7 is equal to 1 over f prime of 7. Okay, it says f inverse prime of 7 is equal to 1 over f prime of 3. Okay, so I'm not looking at the slope of the tangent line of f inverse right here and also of f way up here off the picture here. I'm looking at the slope at these 2 points. They have different x coordinates. One is 3 and one is 7. Okay, but the slopes of these lines are reciprocals of each other. Now, where does this formula come from? How do we derive this formula? Okay, well, I've rewritten the formula up here, and we're going to derive this formula beginning with this formula. Now, we know this is true because this is really just the definition of f inverse of x. F of f inverse of x equals x. Okay, so we're going to begin with this formula that's true, and we're going to use it to derive this formula up here. Okay, now again, this does not mean f times f inverse of x. This is f of f inverse of x. We really have a composition of functions, an inside function here and an outside function. And what we're going to do is we're going to take the derivative of both sides with respect to x. Okay, so take derivative of both sides with respect to x. Now the derivative of the right hand side, the derivative of x, is just 1, of course. Now what's the derivative of f inverse of x? Now notice this is a composition of functions, so the way we take the derivative is using the chain rule. Okay, we have an inside function, f inverse of x, and the outside function is f, okay, or f of x. So the chain rule says the way to take the derivative is to do the derivative of the outside function. So I'm taking the derivative of f, but instead of applying this at x, you apply it at the inside function, f inverse of x. Okay, and then times, okay, the chain rule says we still have to multiply by the derivative of the inside function. So how do I write the derivative of f inverse? Well, we write f inverse. Okay, I'm going to put parentheses around it here to say derivative of f inverse at x. Okay, so we have the product of these two things. This times this is equal to 1. Okay, product of these two things is equal to 1. Now if we divide both sides by this term here, okay, both sides of this equation by this term here, what are we left with? Okay, we're left with f inverse prime of x on the left hand side, that's this term, and on the right hand side we have 1 over this, f prime of f inverse of x. Okay, and this is exactly our formula. Okay, so that's why our formula is true. We take really the definition of f inverse, says the f of f inverse of x is equal to x, and we take the derivative of both sides of this equation with respect to x, and we get the formula for the derivative of f inverse of x.